In this video we will describe what is K-means clustering. K-means clustering is one of the centroid based clustering category. Like we saw two type of major category of clustering techniques, one is centroid based or continuity based. K-means is actually from the centroid based clustering algorithms. Let us look at this data. It is a response of 3-point Likert survey which is having 10 questions. Ignore the x axis the numbers or y axis, consider this is a scatter plot you have, and this is plotting basically the students say the average score or the score they given or addition of score, something like that. So, there are, say we collected around 200 students scored 3-point Likert survey questions, you are plotting in a scatter plot. You want to see whether these students survey has some clusters. For example, if it is a 0, 1, 2, if it is a number considered as a student ID, you want to see among the students is there a cluster, is there a pattern, can you group them into something. If you ignore the x axis, consider this is the scatter plot you have, you can form clusters. So, how many clusters can we make from this data? If you want to group them into say n groups, 2 groups or 3 groups, 4 groups, how many clusters can you form from this data? So, let us say we have 2 random points, the 1 point here, the 2 point here, the 2 random points, and so we can create a clustering moving these random points over this figure, and 2 random points means I am trying to create 2 clusters from this plot. Okay. So, what it happens is it tries to identify the nearest point to the center, and all the point nearest to the center will be considered as a cluster, and all these points near this center will be considered to another cluster. After creating 2 clusters, it identifies again the mean of all these values, the mean value will be the centroid value for the new cluster. So, then it iterates further until it reaches the convergent point, then it creates a 2 cluster. So, let us see how these 2 random points vary. So, consider 2 points has been moved here, and this can be 1 cluster, this can be second cluster. Okay. Let us see what is this distance and how this distance is calculated. Consider this this data, okay. Consider this data, and we have seen this data in a previous classes. Okay. We have students attendance and students midterm marks. Okay. We do not know what is the end sum mark or anything. So, we have students midterm marks, the attendance till midterm marks, we have the plotted in a scatter plot. We would like to cluster them because it is unsupervised learning and we do not know what we are trying to predict. We want to know what is happening with some students who are getting low score. Is there a pattern exists between attendance versus midterm marks? We do not know, but we have some hypothesis, might be a pattern with attendance and midterm marks, can we check it? So, let us see, these are the students plots. I randomly selected 3 points. So, I said 3 is my cluster. So, I wanted to create 3 clusters, randomly selected 3 cluster points. So, point 1, point 2, point 3. Remember that I have only 2 variables here. If I have more than 2 variables like 3, 4, 5, we are collecting more variables, you can't plot it and see how many clusters to come up with. So, let us consider the example of 2 variables in this plot and see how this clustering works. So, I randomly selected 3 random points, and these random points are here. So, what happens is this random point is checking the distance between all the available data points. Okay. This random point, this is a centroid, first centroid. So, the K is 3, there are 3 clusters 1, 2, 3. So, I put 3 clusters in this data. So, each cluster centroid is called cluster centroid. Okay. This cluster centroid measures the Euclidean distance between all the data points in the figure. Okay. So, when it measures the Euclidean distance between this point and also the same point is measured Euclidean distance between this centroid. Okay. This centroid Euclidean distance is large, this centroid Euclidean distance is less. So, what happens, this point will be considered as a part of this cluster, not this cluster. Similarly, this particular data point is very near to this centroid compared to this centroid. So, this will be formed as a one cluster. Okay. For example, this Euclidean distance of this is near compared to this. So, this will be another cluster. So, how to identify the Euclidean distance? So, what is Euclidean distance? So, Euclidean distance is a point distance between centroids and data points is computed by this formula. So, C is the centroid. So, this is C 1, consider this is C 1 and this is C 2 and this is C 3. And x may be x 1, x 2, x 3 and all the points, okay, 1, 2, 3, 4, 5, 6, 7 and other points. So, x will be this x 1 to n, it is number of data points you have. So, you have to compute a Euclidean distance between each x 1 to n to C 1, C 2, C 3. So, this Euclidean distance is computed. So, what is Euclidean distance? In a plot, if you want to compute Euclidean distance, this is actually the vector distance between these two. If you know how to find vector distance, it is simple, it is like so why the mod, because it can be negative and squared, so we do not care. So, that is a squared Euclidean distance. Let us see how this compute the Euclidean distance between 2 points. So, there is a point here, there is another point here. If you want to find the Euclidean distance, we have to compute the Euclidean distance from the straight angle, right. So, the distance, the minimum distance between these 2 points, but we do not know how to compute. So, simple Euclidean distance actually considers this, okay. So, 90 degree. So, we know the distance between these 2 points in the x axis, right, and also we know the values of x1 and x2, y1 and y2. This is a right angle triangle. Now, you know how to compute the value of this if you know the value of these two, because x2 minus x1 is this, y2 minus y1 is this value. So, you know how to compute it, though this is how you compute the Euclidean distance. So, that is it, it is simple to do. So, yeah, check it out if you are not came across this term called Euclidean distance. It is very simple to compute and it is logical, intuitive also to compute distance. There are other distances to compute, not just Euclidean distance in clustering, Manhattan distance or some other distances, but let us see we use Euclidean distance for this clustering technique. So, what happens is the centroid computes the Euclidean distance of all the points, then whichever the point which is near to the cluster, it will be considered to be that cluster. So, let us see the next point. So, after it picked 3 points, what happens is let us look at back. So, consider these three points are considered to be one cluster and these are part of another cluster and these are all near to this cluster, okay. So, this particular centroid, these 3 points are near to this centroid, these points are near to this centroid and these points are near to this centroid. So, based on that value the 3 clusters formed. After you do that, the new centroid will be computed by finding the average value of these 4 points. So, there will be average value of these 4 points. Using the 4 points average, the new centroid will be computed. New centroid might come here, the C2 will move here. Similarly, these 3 points, if you compute the average of these variables, it might come here, C1 might come here. Similarly, this, if you compute 1, 2, 3, 4, 5, 6 points and the new centroid might be somewhere here. So, this will be moved here. So, the new centroid of this cluster will be C1 here and C2 here and C3 here. So, that is how the 3 clusters formed. So, the first step is you compute the Euclidean distance of centroids to all the data points. After finding the data points which is new to the centroid, you compute the new centroids based on the clusters values, that is a mean value. So, now the centroids is moved here. After moving this, again compute the Euclidean distance of centroids to all the data points. Obviously, these 3 points are very close to this. So, this is one cluster and these points are very close to this cluster and maybe, so this is close to this cluster. So, there are 3 clusters formed as of now. Again, if you compute the centroid, if you try to compute the mean of these 3 points and move, it is already the mean computed. So, there is nowhere to move, it is already in the central place. So, if the centroid is not moving, then you stop iterating, okay. That is where you have to stop saying that hey, there is no change in centroid movement or there is no change in changing the one data point one cluster to other cluster, then you consider stopping. If that not happens, so you say a small threshold value, if centroid is okay moving with this limited threshold, it is okay, keep it out, because some cases we do not get the exact clusters from the K-means clustering algorithm. So, you can have a threshold value, it is okay, 1 or 2 points can move and I want to stop it, okay. Or you can say I want to iterate over 100 iterations, I do not want to do beyond 100 iterations, that is fine. So, you can stop based on number of iterations or with some threshold or no change in movement of centroids, okay. So, this 1 cluster, 2 cluster, 3 clusters formed. Now, I hope you know what is K-means clustering. It is actually trying to find the means of the data points from the 3 centroids or number of K centroids we give. Why can't you go ahead and list down the steps we saw in the clustering operation in the previous slides. List down the steps, like first step, what is the first step in your own words, does not matter what you write. So, in your own words, the first point is randomly assign K clusters, 1 or 2 or 3 K clusters, then you do the Euclidean distance and do move the centroid. So, write down how do you move the centroids, write down those steps. After writing it down, resume the video to continue. I hope you would have written down the K-means algorithm. This is the algorithm of K-means. First step is select the value of K. So, the K can be 2, 3 or anything. Why we have to pick 2 or 3, why, which number is good, we will talk about that. And after selecting the value of K, randomly assign the K points. So, the centroid, the initial centroid points are randomly assigned, okay. That is a key, okay. Remember this. I select K value equal to true or 3, then I randomly assign these K points centroids maybe in one corner, or it can be randomly split in the chart. After that, compute Euclidean distance between the K points to other points, to other data points, compute all, then create a cluster which is near to the centroid, okay. All the points which are near to the centers are created to create a form a cluster. After you create a cluster, compute the centroid, that is compute the centroid, the center value, that is the mean value or center value of all the data points in the cluster, that will be the new K point, okay. That centroid is moving to the average or the center of this all this data points, that is a new K point. So, you have to compute a centroid again of the data points of the newly formed clusters, and that centroid will act as a new centroid, new K point. So, now the number of K's is still same, okay. The number of K's is not reducing, we are just moving the centroid here and there. Repeat again, repeat this process again until you see the errors values is very less, there is no change, or you have set in 100 iterations or 50 iterations. So, repeat the points like the computing the Euclidean distance and compute the centroid again and again till you reach the no change in the centroids or the number of iterations reached, okay. This is the K-means algorithm, this is the basics of K-means algorithm. If you written down this, that is right, you already understood the K-means algorithm. If not, please go and watch the video again or go to internet and check the resources. There are some good simulators available to show how these K points are moved, how they is computed. So, check those videos. Okay, then now we have to see how to select the correct number of K. I said that hey, there is a K, can we select 2, 3, 4 or what is the number you want to select. So, in order to select the correct number of K, first you have to identify the error function or the objective. The objective is keep the error function list. What is this error function? What is the objective? Say let us consider the objective is J, okay. The error function value is J. It is actually the distance between centroid and the data points. After you complete the iterations, after you say you set up with the hey, there are 3 clusters, I am not changing anything. After you compute it, suppose for example say let us see. So, okay, this is the centroid, this is the centroid and this is the centroid. So, there are 3 centroids, okay. There are 3 centroids, okay, the 1, 2, 3 centroids. In each centroid, okay, so let us see the 3 centroids, it is only one, it is just I, okay, I do not know, it is just I, and just I, okay. Within the 3 centroids, okay, and there will be lot of data points in this cluster. In this cluster there might be like 3 data points. So, compute distance between centroid and data point. So, compute the distance between centroid. So, summation of all this distance. So, C1 to x1 plus summation is like a C2 to x2 plus C3 to x3, the distance between centroid and x1 and x2 x3. So, there are 23 points. So, this cluster has number of data points in ith cluster is 3. So, here Ci is 3, here there are 4 points. So, here Ci equal to 4, here 1, 2, 3, 4, 5 points. So, Ci equal to 5. So, first you iterate here and you identify for cluster 1 I identified 1 values, plus for cluster 2 what is the cluster 2 that I equal to 1 to cluster 2, that is distance between the centroid and point, this cluster distance between the centroid and data points. This error function we call it as error, plus I equal to 1 to C3 and error function. If you have this distance computed, you some other thing, that is the objective function. So, our objective is to reduce this distance between these clusters as much as possible. You can create more clusters. If you create more clusters, the distance might even reduce further. So, just a quick question, consider I have 3 points, 4 plus 5, 9 plus 12 data points, right. What if I choose k equal to 12, what will happen? If I choose k equal to 12, check carefully, like if you check it well, there will be 12 clusters, okay, which means the center of cluster is actually the data point and the distance between data point and cluster is 0, right. If you 12, if you add the error of all these values, it will be 0. So, if you choose k equal to number of data samples, the value will be 0, okay. If I choose only one cluster, okay, only one cluster, then this complete will be one centroid, that value will be the maximum error function, okay. We do not know, we can't say what is the value, it changes based on the data points, but that will be the maximum error function. If you choose k equal to number of data points, it will be 0, okay. So, now what we have to do, you have to compute this j objective function, and for clusters k equal to 1 and k equal to 2, k equal to 3, you have to compute for different case, okay. Let us see. If I plotted it for cluster 1, 2 clusters, 3, if I computed that previous what I was saying was sum of squared errors, that is objective function j, if I computed for k equal to 1 cluster, this is the maximum value you can get, and if you go, there are like 12 points, say if it is 12 here, it might be 0, the point might sit here, okay. So, now if I compute it, I can plot it like that, right. So, how many cluster we should consider, what is the k value, which k value I should pick, that is based on this curve. If you plot this curve, you can say this is a elbow curve, right. So, there is a bend here, there is a kind of elbow, just your our elbow. So, this is like our hand elbow. So, this particular this is like our hand, and the elbow point is considered to be the optimum k value. So, for this particular data you choose k equal to 3, that is the best optimal value. So, you can choose k equal to 3 clusters, and why we choose that, I will tell you the reason. For example, for k equal to 1 to 2, for k equal to 1 to 2, the difference in sum of squared errors is say some 55 to 80, say 25 points. For 55 here, say 25 here, this difference is 30, but this difference, you know, is just a 5. So, the sum of squared error reduction is really less from 3 to 4. So, that is why we are saying that we will pick the 0.4. So, the sum of squared error will be really less going forward. So, do not pick the cluster equal to 12, which means every data points is the cluster, that makes no sense, and so pick the cluster which is elbow point. So, k equal to 3. It always worked with this k elbow point here, and check it out. You create your own data and try clustering algorithm and see if this elbow point works or not. So, now I hope you know what is k means clustering and you know how to pick the right k value, and if you understood, can you list down 2 drawbacks of k means clustering based on your understanding? What are the drawbacks? You might ask a lot of questions, is the k is correct, what is this, lot of questions, what are the drawbacks? Can you list down 2 of them? After listing it down, resume to continue. So, initial centroids, right, I said you pick k equal to random value k equal to 2 or 3 and centroids assigned randomly initial centroids. That is a tricky part, because where we are assigning the centroid makes the different type of clusters. In a 2 variable it is easy to see, but in a 3 variable or 4 variable it is really tough, and it will not work for categorical data, also for non-linear data sets. So, to handle that there are techniques. So, what is initial so let us see, there are points like this. If my initial centroids I choose 3 clusters, my initial centroids are here compared to my initial centroids are over here, or my initial centroids are here. So, based on where you choose initial centroid, in the two parameter variable it is easy, you know, wherever you choose it tries to merge converge into particular point, consider it is 4 dimension or more than that, and the initial centroid where you choose centroids matters a lot. To avoid this problem, you can randomly select the initial data points and do it for multiple times. So, what I mean is, consider for k equal to 2, the 2 random points might be somewhere here when you assign it. So, iterate the k equal to 2 multiple times. Check if your k equal to 2, if you do the same clustering, same data, say multiple times, say 3 times, 4 times or 5 times, check the number of clusters or the j value is same, then you stop it. Similarly, for k equal to 3, iterate for 10 times, or k equal to 4, iterate for 10 times. In each time you have to iterate multiple times to find right clusters, right centroids, that is within the k-means clustering. What I am saying is, run the k-means clustering for k equal to 2 multiple times. Okay. So, take k equal to 2 and run the k-means clustering for say 10 times. Similarly, k equal to 3 and 10 times, and find which value is most closely, pick those value as a j, or pick the minimum value or pick the mean value, something like that. Then you plot the elbow curve or the bend, then you pick the right k. That is the best option we have to avoid the initial centroids issue in the k-means clustering. So, in this video we saw what is k-means clustering, and we discussed how to select the right number of k using the elbow curve. So, hope you understood k-means clustering. If you do not get what is k-means clustering from this video, I recommend you to go and check internet videos. There are a lot of simulations to explain k-means clustering. I am not talking about the mathematics behind the centroid computation and everything, because that is not needed for this course. The idea for this course is, if you have a data and if you can apply k-means algorithm, you have to understand which k to pick, what is k-means algorithm is, what is clustering means. If you understand what is k-means algorithm, how to pick the number of k, perfect, that is enough for this course. But if you want to know more about k-means algorithm, please refer the data in the website. Thank you.